Welcome back. This is the second lesson recording for IM2, January 21st, 2021. So we should have just finished the decimals, card number 1 to 8. What should we have discovered? Some other key points. You should have discovered that vertex is -1, -32, where the direction of the y value, how the y value is changing, changes. So up to -32, the y values are decreasing, and then from -32 onwards, it's increasing. So -32 is the lowest value, and that's why it's a minimum. Does not get any lower than that, so it's a minimum of -32, and it has the coordinate of -1, -32, and look what happens to the other value, -1. -1 is the line of symmetry, axis of symmetry's equation. So x is equal to -1. So for the vertex, the x value gets used as the line of symmetry equation. The y value is the minimum or the maximum value. Something else that you should note is that notice that you have for the y value -30 and then -30 here. They match up. And then we have -24 and -24 that match up. And then -14 and -14 that matches up. And 0 and 0 and 18 and 18. So you should discover that when you have a table, the y values have a matching pair. So each four, and it is it surrounds the vertex. So that means that the vertex is the one in the point without the matching value, or the one in the middle of all the matching values. Okay? And the reason we have this matching value is if I graph this, look what's happening. There are two numbers with the exact same y value. Two numbers with the exact same y value, and so on. Right? So that's because it's symmetrical about the axis of symmetry right there. Okay, so that is the reason that the lines match up. And so which means that if for some reason you have say 1, 2, 3, 4, 5, you do not have these values, or you are getting too lazy and you are pretty certain that all these values are accurate, and you know that this is vertex, then you can actually even figure out by mirroring the numbers what these values are. Okay, so that's something else that you should notice. Moving on, what else should you have noticed? For the x-intercept, we looked for where the y value is 0. So y value is 0 is here. Okay, so that means -5, 0 and 3, 0, they are my x-intercepts. And for y-intercept, we look for x value to be 0. Okay, so notice that they are opposite. So y-intercept, you do not look for y value to be 0, you actually look for x value to be 0. So, and that's 0, -3, 30. And you can, okay, and you can see that on the graph as well. Where does the graph cross the x-axis? That's the x-intercept. That's at 5, 0. I'm sorry, 3, 0 and -5, 0. What about the y-intercept? Where does the graph cross the y-axis? That's at -30 right there. Okay, but so what we did on the decimals activity from last week or last lesson and today is, so far when we are given an equation in standard form, we created a table, a t-chart, and then graphed them and found our x-intercepts and y-intercepts and so on. But is there an easier way? How can I sketch without a table? Is there a way to do so? Yes, there is, and this is much simpler in many ways. So to do that, we are going to use the fact that when we're talking about x-intercept and y-intercept, So for x-intercept here, the y value of every x-intercept is 0. Okay, so you're going to have some x-coordinate, that's the first number, and the second number is always going to be 0, which is the y-coordinate. Okay, and for the y-intercept, the x value of every y-intercept is 0. The x value, not the y value, x value of a y-intercept is always going to be 0. Okay, so y could be positive or y could be negative, it does not matter, but where it crosses, the x-coordinate is always going to be 0. So we are going to use that fact. So to find the y-intercept, we're going to set x to be 0. And so to find the y-intercept of the graph of y is equal to negative x squared minus 2x plus 8, you're going to substitute 0 in for x and calculate for y. So this is my original equation. That means every time I see an x, I'm going to put 0 in there. Okay, what happens? Y is equal to negative 0 squared minus 2 times 0 plus 8. 0 squared is just 0. 2 times 0, anything multiplied by 0 is just going to be 0. Okay, so the first 2 cancels out and you're left with positive 8. Okay, and if I was to graph it, this is where the blue is my graph. Where does it cross the y-axis? That's my y-intercept. That's at positive 8. That's the value that you get. Okay, so that means the coordinate of the y-intercept is going to be 0, 8. Alright, so then I would like you to try to do this yourself. What is the y-intercept for the graph of y is equal to 2x squared plus 5x minus 12? And then when you're done with that, I would like you to try to tackle the rest of the problems here. Okay, so and when you have your answers, please enter in private chat and I can give you a quick feedback on that. What equation would we need to solve to determine the x-intercept of the graph y is equal to 2x squared plus 5x minus 12? Okay, when we're trying to find the y-intercept, we set the x to be 0. We substitute x to be 0. What do you think we would do for x-intercept, knowing that with any x-intercept, y value is always going to be 0? Okay, so please try to do this, and including D. Alright, so let's go through the answers. For B, what is the y-intercept of 2x squared plus 5x minus 12? Y is equal to that. To figure it out, you're going to substitute 0 for x and calculate for y. So substitute in 0 wherever you see an x. So that becomes 2 times 0 squared. 0 squared is 0. 2 times 0 is also going to be 0. Anything multiplied by 0 is going to be 0. 5 times 0 is going to be 0. So you're just left with negative 12. So y is equal to negative 12. And if I was to graph it using Desmos graphing calculator, and this is a great way for you to check your answer as well. And so I am going to recommend that you do that as part of your homework. Okay, so you can get the Desmos graphing calculator, and I'll put the link in the homework as well for you to be able to look at. Okay, so here you can see that y-intercept is negative 12. So it's right there. The y value of the y-intercept is negative 12. That's negative 12. So the coordinate is going to be 0, negative 12. Okay. Now, there is a shortcut for finding the y-intercept of a quadratic equation in standard form. So standard form is when, remember, standard form of quadratic expression was ax squared plus bx plus c, where you're putting it in the highest degree first, followed by the x term, and then followed by the constant. So this is in standard form. If this is in standard form, the easiest way to find the y-intercept is to substitute 0 for x. So y-intercept. Then when we do that, does not really matter what is the number in front of the x squared or what number is in front of the the x term, because anything multiplied by 0 is just going to become 0. So this term becomes 0, b times 0 becomes 0, so you're just left with c, which means that y-intercept is always going to be the value of the c constant, the very last term right here, without any variables attached to it. That's always going to be the case. And that was the case with our two previous examples, the one that you did and the one that I showed you as well. So I want you to tell me in private chat, what is the y-intercept of y is equal to 3x squared plus 5x minus 2? Okay? Yes, you can go through by substituting x to be 0 and then figure this out. Or if you understood this, you can say, oh, it's just going to be the constant. So that's going to be negative 2. So it's going to be negative 2 is my my constant here. So that means the y-intercept is going to be negative 2, and it is. And that's the graph. Next question, what is the y-intercept of, in this case, y is equal to negative 1 over 8 x squared plus x minus 6. So again, it doesn't matter what this number is. It looks quite complicated, and you might think, oh, I don't know. But when you substitute 0 for x, 0 times anything is just going to be 0. And you add another 0 to it, it's still going to be 0, and you're just left with negative 6. And if I graph this, you will see that the y-intercept, where the red graph crosses the y-axis, is going to be negative 6 there. Okay, and that proves that that is true. Okay, now we're going to try to talk about the x-intercept. Is there a way? Well, what equation would you need to solve to determine the x-intercept of the graph y is equal to 2x squared plus 5x minus 12? Well, what do we know about x-intercepts? We know that every x-intercept has the y-coordinate of 0. The y value is always going to be 0 if it's going to be x-intercept. So we can set the y to be 0. So this equation becomes 0 is equal to 2x squared plus 5x minus 12. Okay. Now what? Okay. What do we do now? How can we solve this? The solution to the equation 2x squared plus 5x minus 12 is equal to 0 are called zeros of the function, because you're setting something to be 0. Okay, that's where the word comes from. Y is equal to 2x squared plus 5x minus 12. At this point, can you algebraically solve the equation? Explain why or why not. And I'm going to give you a hint. Try to factor the left-hand side. Okay, left-hand side is just a quadratic expression. Do you know how to factor this? Hopefully you're going to say yes. And if I factor this, I am going to get 2x minus 3 multiplied by x plus 4. Okay, you can use diamond method or area model. I mean, you have to use diamond method and then followed by a grouping method or area model, or if you have some other method, that would be fine as long as you can show your work. But anyway, once you've factored, you should get this. Okay, so you are told that 2x minus 3 in parentheses times x plus 4 is equal to 0. So what? Okay, what are we supposed to do now? Well, that's where we come to zero product property. Okay, and to explain this, I am going to continue in our next lesson recording.